Alright, so we talked about comparing sides and angles and inequalities in one triangle with your triangle inequality theorem and that good stuff. What happens now when we compare two triangles? So now we're just basically going to extend what we've been talking about and look at how we can compare sides and angles of two different triangles. So let's talk about the hinge theorem first. So let's go ahead and write down the hinge theorem. If two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is across from the larger included angle. So remember, the included angle is the angle that's between the two sides that are in the problem. So if you remember how SAS looks, it's that angle for SAS. But let's talk about these two triangles. So let's call this triangle ABC and call the second one XYZ. Alright? So if you look at what the theorem states, excuse me, it says if I know that two sides are congruent. So for example, if I know AB is congruent to XY and AC is congruent to XZ, those are the two congruent sides. And then I'm given two included angles that are not congruent. So notice that's important. The included angles are not congruent. So for example, these are the included angles, right? Angle A, because it connects the two sides here, AB and AC. And the other angle X is the included angle for the other triangle, because it connects YX and XZ. Those are not congruent, so notice they have two different markings. So what this theorem tells us is that, well, the third sides are not going to be congruent, because SAS clearly doesn't work here. But so that means one side has to be larger than the other. How do I know which one's larger? Well, look at the angles. So if, for example, we know angle A is, oops, let's make that a little bit clearer. So if I know that angle A is greater than angle X, in addition to all this stuff, so all together, plus I know angle A is greater than angle X, then I can conclude that the side across from the larger angle is the longer side. So then I can conclude that BC is greater than YZ. And that's the hinge theorem. And I think of it as a hinge because that angle is like the hinge when you're opening a door and closing a door, right? So that's what that looks like. Alright? Now the second theorem is the converse. So the converse is basically just the reverse. So let's write that down first and then we'll look at the diagrams. So the converse says if two sides of one triangle are congruent to two sides of another triangle. So notice how that repeats. That has to stay the same. But this time the third sides are not congruent. Then the larger included angle is across from the longer third side. So once again, it's the included angle. And this time we're not given information about angles, but we're given information about sides. But you want to see how, notice these two sides of one triangle are congruent to two sides of another. That is still the same condition that we talked about earlier. So that still needs to be true. So now let's dig into the diagram and see what does this tell us. So let's call this first triangle DEF. And I'm just going to move my screen a bit. There we go. And let's call this one WVU. Alright. And once again, we had to be given that two sides are congruent. So what if DE is congruent to WV? Right? DF is congruent to UV. Those are my two congruent sides. But I had to know that the third sides are not congruent. So, for example, what if we knew that EF is greater than WU? Right? So, that is the information we need to know before we can make any conclusion. So this plus everything in that diagram. Now, if I know all this stuff, then I can conclude that the larger angle is across from the longer side. So if EF is the longer side, the larger angle should be across from EF, which is D. So the measure of angle D is greater than the measure of angle V. And once again, those are the included angles, right? So we're looking at the angle between the two sides that are given, right? All right, so that's the converse of the hinge theorem and the hinge theorem, and we can use them to solve problems. For example, like example 1, I want to compare these two angles. So remember, the first thing you should do is actually locate the angles. So let me highlight what these angles are. So BAC, start at B, go around to A, then go to C. That's the first angle, right? So that's BAC. And then I want angle DAC next. So go to D, go around to A to C. That's this angle. Okay? So remember, to use the hinge theorem or the converse of the hinge theorem, we need to have two congruent sides. So it's pretty easy. I've got 4 and 4, which are congruent. Awesome. But you might be saying, wait, I've got a 6 and I've got a 7. Those aren't congruent, so this doesn't work. But don't forget, AC is congruent to itself by our favorite reflexive property. So there's your second congruent side. All right? So then, in order to talk about these two angles, we want to look at which side is longer. So since BC is the longer side, that means the angle across from it, angle A, or angle BAC, excuse me, has to be the greater angle, right? By the converse of the hinge theorem. Alright, that's example 1. Let's move on to example 2. So remember again, we need to know two sides are congruent. So which two sides are congruent here? Hopefully you see EH and HG are both 7 and 7. There's an obvious given. And then we've got this reflexive FH. And what I want to do is I want to compare these two sides, EF and FG. Well, EF is across from this 82 degrees. But what about this FG? Well, I need to know the measure of angle FHG first, right? Well, how do I know that? Well, what are these two angles, EHF and FHG? Well, remember, they're a linear pair. So that measure of angle EHF plus the measure of angle FHG should add up to what number if they're a linear pair? Well, they should add up to, oops, move my screen again. They should add up to 180 because that's a straight line, right? So just plug it in and solve. So the measure of angle FHG is equal to 98 degrees, right? So now I have that information, I can determine which side is longer, right? So of course the longer side needs to be across from the larger angle. And notice these are the included angles because they're between our two congruent sides. So what's my conclusion? I should conclude that FG is larger than EF, and that's by the hinge theorem. And remember, don't be too caught up on vocabulary like this. For these theorems and stuff, if you're using them in a proof, it's okay to just describe it. Alright? Example 3. Now let's talk about a range of values. So this is kind of like what we did earlier in the last set of notes when we were dealing with a range of values for the third side. So we want to think, what could K possibly be? Well, remember, when we're comparing our two triangles, we need two congruent sides, right? So here's one pair. That's given. Awesome. Remember, what makes ln congruent to itself? Well, that's your reflexive property. Okay? And then we want to take a look at the side lengths right here. Oops, I meant to highlight that. Let's take a look at these side lengths, right? Which one is the longer side? Well, MN is. That's greater than PN. Therefore, those included angles across from those sides should have the same relationship. So that means the measure of angle NLM, which is across from MN, should be greater than the measure of angle PLN, which is across from that 18, right? Then that's your converse of your hinge theorem, right? Now let's go ahead and plug in your values. All right, and here's just algebra, so solve for K. All right, K is less than 10. Done? No, we are not done, because think about numbers less than 10. K could be negative 75, and if K is negative 75, could I have an angle that's 5 times negative 75 minus 12? No, because it's going to be negative. So be careful. Always remember to check this right here, the given expression 5K minus 12, that has to be greater than 0. No angle should be less than 0, right? So check this inequality as well. So if 5K should be greater than 12, oops, let me clear that up again. 5K is greater than 12, and then just divide. So K should be greater than 12 over 5, right? So then you can combine these two together to make a range of values. So you can keep this as a fraction if you want, or you can write, 2.4, it's up to you. But here is your final answer. Excuse me. All right, almost done. Remember to make sure you come back to class with questions, if you have any here. But let's do a direct proof. I know we spent some time earlier, doing indirect proofs, but now let's do an actual direct proof. And I didn't realize I had some typos, so I'm going to put the segment lines above those two. All right. So I am given AB is congruent to CD, which is right over here, right? And angle ABD, that measure is greater than angle CBD. How do I prove that AD is greater than CB? Well, let me set up my proof. And remember, you can do your proof in any format you'd like. I like the 2-column format, but you could, excuse me, I think flowcharts are also great to show your brainstorm and how you're thinking. So I'm going to go ahead and start with my givens. Excuse me. So those are my givens. And then I'm going to take that and use something I learned today. So I want to look at perhaps the hinge theorem or the converse of the hinge theorem to prove the side lengths. And what I want to remember is I want to think, well, wait, we're talking about sides. So we're comparing sides. That's the regular hinge theorem. So I know my final statement will deal with the hinge theorem. All right, so that's, again, my brainstorm, and I know how I want to end that. So in order to use the hinge theorem, remember, I need to know more than one side is congruent. I need to know we have 2 congruent sides. So do you see another pair of congruent sides? Because I do. It should be right here with BD. And remember what that reason was? BD is congruent to itself by what we call a reflexive property. Right? So now I've got 1, 2 sides, and I know the included angles. ABD and CDB, that's got a relationship here, right? ABD is greater than CBD. So then I can just finish this off and say, well, if 2 sides are congruent and I have one angle larger than the other, then the larger side is across from the larger angle. So just check. ABD, is that across from AD? Yes, it is. So that means AD is my larger side. And that is the hinge theorem. And that's my proof. So come back to class with questions. I know it can be confusing because we just did an indirect proof, but that's a direct proof. You should know how to do both. And I will see you guys later.